Welcome to Refactoring to Clean Code vlog. My name is Włodek. I am Clean Code and Refactoring trainer. I write a blog at www.refactoring.pl, and today I will show you how to change procedural code into object-oriented code. Which style is better? We will see. It depends. But before we go further, as the name of the blog is Refactoring to Clean Code, I will talk a little, each time differently, a little about clean code and refactoring. So, what is clean code? Do you know? Have you ever thought about any definition of clean code? There are many, and I think that the simplest explanation is that clean code is code that is easy to change and easy to understand, whatever it means behind it. Sometimes it might mean very simple design, sometimes very complicated design. The key point is that it should be easy, fast to understand, and easy to change, easy to add new functionality into given code. And what is refactoring? Refactoring is a technique that allows to make your code clean. There are also many definitions. Here is mine. Refactoring is a set of code transformations performed in order to achieve clean code. In a minute we will have a look at sources that I have prepared. Very simple sources that I will use to perform transformation from procedural style into object-oriented style, and also to start a discussion about which style is better, procedural one or object-oriented one. Here is our source code. Let's have a look. It contains circle structure, rectangle structure, square structure. Very simple, three, as you see, structures. And it contains geometry class as well. The geometry class, as you see, contains only one method, but you can imagine that there are other similar methods here. And is it good design? You might not like it because Java programmers and others usually prefer object-oriented style over procedural style, but it depends. Why? Imagine you have 10 such methods and 11 such a method is going to be introduced, and the set of shapes is constant. It is not likely that new shapes will be added into our system. And in such a case, most likely, if I add one more 11th such a method, the method will be added, but the existing code is not touched at all. So it is very unlikely that I will break existing functionality. On the other side, if it is very likely that I will be introducing new shapes, then each such a method needs to be enhanced, changed, modified. So it is likely that I will or I might break something. So the direction of extensions matters and might have significant impact on the design we should or might choose to follow. Of course, we have a set of tests. You can just believe me that these tests are green. When you download the sources, you can run these tests and see that these tests are indeed green. So if it is likely that the set of shapes is going to grow, then maybe we should go towards, like this, more object-oriented design, where the logic, as you see, is put into each class implementing shape, and the shape class will contain a set of methods that should be implemented. And in this case, if I add a new implementation of shape like triangle, I implement methods belonging to the interface or to the base class, and that's it. Again, in this case, I am not touching existing code. If you would like, you can download the sources. How to do this? Where are the sources? Just join Refactoring to Clean Code newsletter and you will receive instructions how to download the sources. If you join the newsletter, you will be also informed each time new vlog is recorded and new sources to try together with me are available. So now I advise you to stop the recording for a while, download the sources and then continue. Now as you have the sources, let's go and perform live refactoring. I have divided the live refactoring into many steps, into 5 steps exactly. The first one will be to encapsulate fields within the data structures we have. Here are the data structures: circle, rectangle, square. Where are they created? They are created currently within our tests, like here, here, and here. So I want to get rid of this public. I want to have a getter. Maybe I would like to assign radius through the constructor. How to do this? In the smallest possible steps. Most likely, in reality, there would be a few other places like this one where in this style circle is created. So let me extract this local variable, free radius, put it at the top. I will mark the remaining lines, Ctrl-Alt-M, so it will be, without annotations, it will be create circle for, and now what I can do, radius, the parameter will be passed through the constructor. So I will click Alt-Enter, create constructor. The constructor is present. Alt-Enter, assign parameter to field. Here it is. I would like to limit visibility from public, so I will introduce getter currently by refactoring, which is called encapsulate field. It's here, encapsulate field. I just need a getter and have a look. What related one problem? Definitely yes. Exactly, this is not needed at all. And that's it. I will inline this. I will inline this method. And as you see now, in the first test, I can inline this variable as well. And now, as you see in the first test, circle contains encapsulated data. We will move the logic into this class at some point. I will perform quickly exactly the same transformations for rectangle and for square. So here I will extract as well two local variables, width and height. I will mark these parts. I will extract them into create rectangle. Here it is. We have it. Now I know that I would like the constructor to take these two parameters. Create constructor. We have the constructor. We have the fields. So I can bind constructor parameters to fields. And now, when it is done, I do not need these two lines at all, because the assignment is done through the constructor already. And now I would like the logic which is here to start using getters instead of reaching to the fields directly. So in order to achieve it, I will perform self-encapsulation again. I go into rectangle, I go to the big menu, Ctrl-Alt-Shift-T. On Mac it will be Ctrl-T, encapsulate fields, just the getter. What encapsulate fields does, I forgot to explain. Encapsulate fields replaces reading public fields directly with calling getter and assigning public fields directly with calling setter. So I just need a getter. Here it is. Self-encapsulate field. So it should be for both only getter. Yes, and we have get height, get width, two private fields, and the constructor. And geometry class right away, as you see, is using getters now. And there is one more, which is square. So let's do the same. Before this, let's finish dealing with rectangle. So I do not need this method. I do not need these two local variables as well. Now we have circle, self-encapsulated, rectangle, self-encapsulated, and finally it's square to be self-encapsulated. So let's do this again. Size, the variable has been extracted. Extract local variable, extract method, create square. Yes, I have it. Cool. I would like the size to be passed through the constructor. I have the constructor. I am assigning parameter to field. Now, this is not needed because the assignment happens here. I will self-encapsulate the field as before by introducing getter, and this way the logic in geometry class, as you see now, uses getters, and in square this field is private. I will inline this. I will inline this method. I will inline this local variable, and this way self-encapsulation, as you see, has been performed within all three shapes. In the second part, in the second step, it is time to introduce common base class for all the shapes. Let's open IntelliJ. Here is IntelliJ. Currently, geometry class takes object, Java lang object, and checks instance of square, rectangle, circle. So I would like to introduce a shape common base class. Of course, it doesn't exist, so let's create it. New Java class. It might be interface, it might be class. I want to be a class for now, so I have a shape. So now shape is here, whereas circle is not shape. How to do this? How to correct it? So it looks like shape should circle should extend shape. Rectangle should extend shape as well. Square should extend shape as well. Let's see what's happening now. Let me run the tests. As you see, everything seems to be working correctly. So now geometry takes shape class. And what I would like to do, I would like to move this method or the logic from this method into my new shape class. So here is my next step, move methods. Currently there is only one method to be moved. So here is the content of this method. I want to leave this static method for now, so I will mark this part. I will extract one more method. I will give it a name, calculate area. So everything should be working, but I will do a trick. Here I will add new geometry dot calculate area. Everything should still be working. I will get rid of this static keyword, and now calculate area, this method using F6 will be moved into shape. Have a look. What happened? Geometry class forwards the call now to shape. Shape.calculate area is being called, and the shape, I know it's a smell, a temporary code smell. Shape, the base class, checks, who am I? Which is slightly strange. So we should push this method down into the subclasses, and in each of the subclasses only one, the first, the second, or the third piece of logic will be relevant. Let's do this. So this is my next step, push methods down. Here is IntelliJ. I'm clicking on this method, Ctrl-Alt-Shift-T, push members down. I'm marking the method, I'm marking keep abstract, so abstract definition in the shape class will remain. I'm clicking refactor, clicking continue. Cool. Ctrl-Alt-B. Let's open the first circle and let's have a look. As you see now, we have a few ifs, but only the first one is always true. So when I click Alt-Enter, I can unwrap if statement. That's what remained. It looks like I do not need this. That's redundant. I do not need this as well. Okay, that's it. Let's come back to shape class. Ctrl-Alt-B, open rectangle. Again, calculate area. This is rectangle class, so the second condition is always true. The first one is always false, but the second one is always true. That's it. I will get rid of this unneeded cast. This is not needed as well. Yeah, this assignment was strange, so I'm inlining this local variable, and that's it. One more class, Ctrl-Alt-B, is the square class. Within the square class, the third condition is always true, so the first one is always false, the second one is always false, the third one is always true. Unneeded cast, temporary local variable which is not needed as well, and that's it. Now it looks like, I hope so, that now all the tests, Ctrl-Shift-F10, should be still green. Let's check if they are indeed green. Yes, they are. Okay, now we have a question. Do we need this static method at all? Most likely not. We will inline it in a minute. So, is there anything else that we should do? Yes, I think within circle, these getters are not needed. So we will inline this getter, inline all and remove the method. Within rectangle get width and get height are not needed now, and within square get size is not needed. Within geometry, this local, not local, but this static method is not needed as well. So we can open the test, and now you see, okay, a few other things to be cleaned. So we do not need this, I guess, but it's like this. Here, this cast is not needed as well. Here, this cast is not needed as well. What else? Maybe we should extract this part area and put when one level up, so it is slightly more clear. I'm extracting this as well, and finally I will extract into local variable area this part as well. And it looks like in this case we can very easily add a new shape. Of course, there might be much more methods here, very easily without touching existing functionality. But this design will be much more better than procedural style, especially when new shapes are very likely to come. So we removed that code within the subclasses from if-else statements. If it was a switch, it would be exactly the same. That's all for today. Thanks for watching. If you would like to go more, read my blog about refactoring at www.refactoring.pl. If you join the newsletter, Refactoring to Clean Code newsletter, you will be informed about new episode of this vlog. The vlog will be placed also for free at courses.refactoring.pl. See you next time. Thank you.